All right, guys, so we're going to take a little bit of a look at kind of the last part of some of the brain parts here. So we're going to start with the cerebellum. The cerebellum is kind of this little structure that's located at the bottom of the brain, kind of on the posterior aspect of the brain, right behind the spinal cord. It similar to the cerebrum, has two hemispheres. All right, and it is what's referred to as a convoluted surface. So it has a lot of these little ridges and folds and things in it. To me, what it really looks like is a almost a tree branch or a tree leaf. So you've got these kind of forks that come out through the center, and then it's got these little structures that kind of extend away from that. So it almost looks like tree branching or veining of a leaf, kind of to me. You'll see a little bit more of that when we go through the video for the sheep brain dissection. And it's really responsible for kind of these things. So regulating our balance, posture, a little bit of movement, and then as well as muscle coordination. So those are the big key things that really does for us. Okay. Um, this is again just showing you another picture, kind of a diagram of the cerebellum. So this is that structure out here at the back, and I think it's a little better, a little more clear here. And here you can see that kind of veining, almost kind of leaf diagram kind of idea there as it kind of goes through. There are also a couple structures that actually help protect the nervous system. We've got three main things. You've got your scalp and skin. That's where your first line of defense. You've got the skull and the vertebral column kind of protecting the spinal cord, the skull protecting the brain, spinal cord protecting the vertebral column protecting the spinal cord. And the last portion here that we have are what are referred to as the meninges. So we'll go through each one of these kind of a little bit. And you can see the layers that we have here. So here's your scalp up here at the top. And then you've got kind of this periosteum, this kind of connective tissue underneath it that kind of holds the scalp to the skull. The scalp, for the most part, is movable, but it is kind of attached to the skull in that way. Here's the skull bone right through here. Right, and then you can see underneath that we've got the what we call referred to as dura mater. So those are the meninges. So there's three different layers there, and then you get all the way down, and then we're finally into the brain. So we'll kind of go through these and talk a little bit about them. Okay, so the first one here essentially is just these are some of the other ones we have. So obviously we talked about this one the other day. So the cerebral spinal fluid, that's the fluid that actually fills the spaces between the skull and the brain. And then there's also a layer referred to as the blood-brain barrier, which actually kind of separates the brain from any blood that would make its way in here. So you can see we've actually got this little space in between the brain called the subarachnoid space right here. So that's right between the blood vessels. That's where the blood vessels kind of form. So for the most part, the brain itself doesn't actually have any blood flow within it. It's all around the outside, and then it's kind of crossed through that barrier there. Okay. So the meninges, there's a couple different portions of it. So we have what's referred to as the dura mater. This is sort of a double layer on the external portion of the brain. And the two layers here, we've got what's called the periosteal and then the meningeal layer. The periosteal layer is directly attached to the surface of the skull. And then the meningeal layer is this outer covering. And you can kind of see it actually in this diagram right here. It almost looks like a wrapper kind of around the outside. It's similar to the heart in that when we talked about the periosteum that kind of surrounds the heart, it's a similar idea. But this is a much thicker, much tougher tissue. And when we dissect sheep brains, you get to see a little bit of this. So you'll see that kind of in the video. And then it actually follows a lot of those folds that are in and around the brain. So it's a little tougher to kind of take off. All right. The other ones we have then are the arachnoid layer. Okay, so this is the second layer of the meninges. This one is more kind of spider web like, and that's kind of the texture it has, or almost kind of like cotton fibers. All right, and then the last one we have is what's referred to as the pia mater. All right, so we have the dura, arachnoid, and then pia mater layers. The pia mater layer obviously is the internal layer, and then this is the one that specifically clings directly to the surface of the brain. So you really can't kind of take that one off, but you can see the dura mater, you can kind of remove it. You can see a little bit of this arachnoid matter that kind of is holding the dura mater to the pia mater. and then the pia mater is directly attached to the brain itself. So it's really hard to kind of remove. You don't really kind of see that. All right, this video, I'll post it. Kind of shows a little bit of removing that dura mater from the meningeal layers. Okay. All right, the last thing here with the protection, or next thing we'll talk about here with the protection, is the cerebral spinal fluid, often referred to simply as the CSF. It's real similar to blood plasma in that it's kind of a thicker, viscous fluid, but it's not real, kind of almost kind of thick. Remember we talked about this the other day. It's formed in that choroid plexus, this little area right in here of the brain. Right, and then it's what it really does for us is kind of provides that watery cushion. So the brain is actually floating inside of the skull there. It's going to circulate throughout all of these spaces that you see down here at the bottom. This might be, especially since it's in bold, a pretty good test question, so just make sure you take a look at that. But it circulates in the arachnoid space, the ventricles, so it circulates within these ventricles that are in here, the center of the brain. The central canal, the spinal cord, so it's circulating down through there. And it's there really to kind of protect that portion of the brain for us, okay? This just shows a little bit of the ventricles you see on both sides. These are the blue areas that you see here in the diagram as well as back here. So those are the portions that kind of form when the brain is kind of folding in on itself during formation. And there's fluid inside of those. So that fluid also helps kind of to keep the brain its shape just a little bit, okay? The brain is pretty delicate, actually, though. So the ones we dissect look much firmer than the ones that we would actually see. So I'll post this video as well, but it actually shows how delicate that brain is. It's almost kind of gelatinous-like or jelly-like in its nature. One of the other layers that we have here is what's called the blood-brain layer. So this is the least permeable set of capillaries that we actually have in the body. And it's for good reason, because we don't want certain substances to get into the brain. So it will keep out those specifically harmful substances that could be for the brain. So there are several substances that are pretty much useless, but it will not keep out some substances. So these list of 5 substances right here can cross this barrier. All right, so anything that's fat soluble or fat itself, that's why it's really bad to take high amounts of fat soluble vitamins. All right, so vitamins like E and K and things like that, if you take too many of those, they can build up in the brain. It allows respiratory gases to exchange, so the brain can get oxygen and get rid of carbon dioxide. Alcohol is one of the ones that will directly cross this blood-brain barrier, which is why people who drink alcohol are affected pretty quickly, because it can get right into the brain. Nicotine is another one, which is why it's become so addictive, because it can cross that barrier. And then the last one is anesthesia, which crosses that barrier, okay? But most other substances can't make it across this. So normally we don't see actual blood on the brain, in the brain itself. We normally see blood around the outside of those layers above, okay? All right, we'll go ahead and stop there. We'll take a little bit of a look at some things later this week. We got some disorders to talk about on Wednesday, and then we'll talk a little bit about cranial nerves, I think, on Friday. We're looking at probably taking our assessment. Right now, we're looking at it probably the following week, so we're looking at probably April, what is that, maybe 20th or 21st right now. So we'll take a little bit of a look at those as we go forward.